Newton's motion laws. I have researched Newton's motion laws. English physicist and mathematician Sir Isaac Newton, most famous for his law of gravitation, was instrumental in the scientific revolution of the 17th century. His three motion laws are following on. Newton's first law of motion. Every object persists in a state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by force impressed. Explanation of first law. Nothing can move unless something forced it, unbalanced force. Something will go on forever in that direction if there was no gravity. If the net force on a body is zero, its velocity will not change. Experiment. Painting on card. Materials. You'll need one plastic cup or a cup, one playing card, and one coin. Procedure. Place the playing card on the cup. Place the coin on the card. Flick the card really fast as the coin will drop. Observation. The coin has interior, meaning it really wants to stay in one place. If you move the card slowly, it isn't fast enough to overcome that force. If you flick it quickly, the coin stays in one place and then drops into the cup. An object at rest will remain at rest. Newton's second law of motion. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the object. Explanation of second law. Acceleration is produced when a force acts on a mass. The more mass, the more force needed to accelerate it. The acceleration of an object of constant mass is proportional to the force acting upon it. Experiment. Ball rolling. You'll need one cardboard trap, one heavy ball, one lighter ball, and a barrier. For example, a tissue box. Procedure. Place the... Mr. Shajin, which ball is lighter? This one. Place the lighter ball at the start of the trap. Let go of the lighter ball and see it go. Place the heavier ball at the start of the trap. Let go of the heavier ball and watch it go. As you see, the lighter ball rolls slow. The mass isn't enough to push the barrier away, while the mass of the heavy ball is enough to push the barrier away. This is because the heavy ball has more force than the lighter ball, which makes the acceleration faster for the heavy ball. Newton's third law of motion. To every action, there is always an equal and opposite reaction. Explanation of third law. When you're forcing an object, it is also forcing on you. Balanced force. A force is a push or pull that acts upon an object as a result of its interaction with another object. A variety of action-reaction force pairs are evident in nature. Experiment. Balloon reaction. Materials. You'll need one balloon and one pumper. Procedure. Pump the balloon with the pumper. Let go of the balloon's neck and watch it fly. Observation. The action of the experiment is that the air rushes down from the balloon, and the reaction is that the balloon goes up. Conclusion. In mechanics, these three laws of motion, the basic principles of modern physics, resulted in the formulation of the law of universal gravitation. Sir Newton presented a theory to invent our modern technologies such as rocket, plane, car, etc. Thank you for listening.